we present Hestia, Voxel-phase-aware hierarchical next best view acquisition for efficient 3D reconstruction. Over the years, 3D reconstruction and novel view synthesis methods have achieved groundbreaking results by leveraging multi-view information from images. However, most images are still collected manually, which is time-consuming and labor-intensive, or through simple pre-planned camera trajectories, which often missed occluded parts. Fortunately, recent works have developed generalizable next best view planners that can actively predict viewpoints for data collection without online learning. These methods have shown promising results, outperforming pre-planned trajectories and reducing human workload. However, the performance of the methods is still insufficient and not robust enough for diverse object shapes. Therefore, we propose Hestia, Voxel-phase-aware hierarchical next best view acquisition for efficient 3D reconstruction to address the challenges. Hestia inherits the benefits of prior work, which also uses reinforcement learning to learn a generalizable policy that can directly predict a 5-degree of freedom viewpoint. This enables Hestia to avoid the online learning process and candidate viewpoint sampling, which often slowed down inference and may potentially miss the best viewpoint. Beyond prior methods, Hestia systematically addresses the shortcomings of reinforcement learning-based generalizable approaches with 4 key ideas. The first idea is to treat Voxel observations as cubes rather than points. The Voxel-phase-aware observation straightforwardly prevents Hestia from overlooking the geometry of the object-centric scene. Beyond the intuition, we demonstrate the benefits of this design theoretically through a constrained example. Assume that k-unit cubes exist in the scene, and the one-ray camera is used to capture ray. From the coupon collector's perspective, treating a Voxel as a point will miss around 22% of the faces when k is equal to 8,000, whereas treating a Voxel as a cube can achieve full coverage. For more details about this constrained example, please refer to our supplementary materials. Directly predicting a 5-degree of freedom viewpoint is challenging due to the high-dimensional continuous action search in space. Therefore, we propose a hierarchical structure that first predicts where to look at and then where to fly. This structure is inspired by professional human pilots, who also decide where to look first before flying to the destination. Notably, the purpose of Hestia's hierarchical structure is to address the high-dimensional continuous action search in space in reinforcement learning, which is largely different from traditional hierarchical structures designed for moving along frontiers. We found that granting a large final goal reward leads to spurious correlations, causing positive rewards to be assigned to currently non-useful actions during reinforcement learning training in the next best view task. Hence, we propose a closed-greedy training scheme that removes the final goal reward and lowers the discount factor in reinforcement learning. Finally, we found that previous RL-based generalizable next best view planners were trained on the House 3K dataset, which only contains cubit-like shapes, i.e. buildings. Therefore, we introduce a larger and more diverse training set derived from Objectverse to improve robustness across diverse object shapes. Experimental results show that Hestia's improvement is not marginal. Hestia outperforms prior methods by at least 4% and 6% in coverage ratio and area under the coverage ratio curve, respectively, while reducing the chamfer distance by 50% in the point cloud reconstruction task. In addition, Hestia trained on smaller and less diverse dataset still outperform prior works, demonstrating that the improvement stems not only from large-scale training but also from the proposed designs. Finally, Hestia outperforms Hestia H3K, validating our claim that using a larger and more diverse dataset is beneficial. Here, we present the qualitative results of Hestia on Omni-Object 3D dataset. The improvement is clearly visible. Here, we present the qualitative results of Hestia on the Objectverse dataset. The improvement is clearly visible. Here, we present the qualitative results of Hestia on the Houses 3K dataset. The improvement is clearly visible. The agent of a next best view planner, such as a drone, usually depletes its battery within a short time. Hence, it is important to evaluate the performance of Hestia under a limited acquisition budget. With a 5-image budget, Hestia outperforms other by at least 12% and by 5% under the 15-image setting. This also shows that Hestia requires only 5 viewpoints to achieve performance comparable to other methods that need at least 15 images. Hestia also performs more robustly with fewer views when the object is placed in different locations within the scene. Qualitative results further demonstrate Hestia's robustness to translations. The ablation study on the observer's test set showed that applying either the closed greedy scheme or the hierarchical structure alone achieves greater gains than using the voxel-phase-aware design alone. This is likely because the closed greedy scheme and hierarchical design is the training process, whereas a voxel-phase-aware design makes it more difficult. Yet, they are complementary. Combining any two of these designs leads to further improvements. And combining all of them achieves the best performance. Here, we present the NVIDIA Isaac Lab demonstration results using Hestia as the next best view planner. Additional results are also provided. Here, we show that Hestia as the next best view planner is feasible for real-world applications by using a drone with an RGB camera as a mobile agent and master to convert RGB images into depth maps. For details of the real-world drone system, please refer to the supplementary material. Here, we present all of Hestia's point cloud reconstruction results on the Omni-Object 3D dataset. Here, we present all of Hestia's point cloud reconstruction results on the Houses 3K dataset. Here, we present all of Hestia's point cloud reconstruction results on the Observer's dataset.